Hello everyone, my name is Vinay Kirgod. Today I will be discussing about bagging approach, one of the ensemble method. So today we will be covering about various ensemble methods, bagging, when to use bagging, one real world example, credit card defaults, and finally recap and the future work. So in ensemble method consists of bagging approach, boosting approach, and stacking approach. So in bagging approach, we train multiple models on a different subset of the original data sets to obtain the final predictions. In boosting, we sequentially train the model to minimize the errors. So we keep doing that until unless we reach the convergence where we cannot minimize the error even further. So once we reach to that point, we will obtain the final model and we generate the final predictions. In stacking, we combine predictions from multiple models using the metadata, or using the meta model. So here we have the original data. So in the image you can see we are saying we are taking the subsets of the original data and then we are training the model on those subsets, and then finally we combine those predictions to obtain the final predictions. So when to use bagging? So if you have a high variance in the data sets, so usually we go with the bagging approach. So if you see the comparison between the single decision tree versus ensemble decision tree, so in the single decision tree you will just build one model, then it will be really hard to minimize the variance and optimize the model to generate the better prediction. So whereas in ensemble model you will generate multiple models to obtain the final predictions, which helps us to minimizes the variance and optimizes the overall performance. So here we will be discussing about one real world example. So credit card defaults. So the real world data sets which consist of financial data and the demographic data, so that you can build a predictive model on that. So the what is the business outcome here for the financial institution? So it reduces the risk, it reduces the financial loss by identifying the high risk clients early, and then it also improves the customer satisfaction and reduces the default rates through tailored financial advice and support. So the data sets, let's discuss about the data sets. So we got the data sets from the UCI machine learning repository, which is an open source data sets. You guys can also download and then analyze from your side as well. So the data sets, the features consist of demographic details, financial history, and the transaction details. So once we have the data sets, so we usually do the pre-processing. So we usually load the data sets, drop unnecessary columns, splits into training and testing sets, and then finally we standardize the features. So I can go over the example here. So in this example, if you are seeing that I'm importing the necessary libraries for me to perform the task. So I have the pandas data frame for performing manipulation on the data frame, and then I have the scikit-learn, which I imported to do like this train, test plate, standardizing, and then importing the model. So here I'm loading the data sets from my local machine. You can change this path according to your convenience, and then I'm pre-processing the data sets, removing the ID and the default payment next month. So which ID, as it's not going to add any value. So basically the default payment next month is going to be used as final outcome, where to make the final predictions. So here I'm using train test split to split the training data sets to split the original data into training and testing. So here I'm considering 80% for training, 20% for testing. Here I'm using this standard scaler. Basically I'm trying to standardize the columns, because if the units are different for each column, then it can significantly impact the final outcome or the final prediction. So we have to standardize the columns so that we can train the model effectively. So once the data is ready, then we use the bagging classifier. Under bagging classifier, I'm using the decision tree classifier, and I'm generating around 50 decision tree classifier. Uh, and then I'm setting the random state as 42, only for the sake of the reproducibility. If you want to evaluate the model over and over again, so this will help us to evaluate the results. And then finally, I'm generating the predictions, evaluation results. So you can see the evaluation results. So overall classifier accuracy looks like 0.81%. It's basically around 81%. So this is how we did from the Python point of view. So basically, to summarize, so The initialization, so base estimator, decision tree classifier, number of estimators, you have like 50 and then random status 42. So basically for reproducibility. And then we train the model using fit function. So it trains the model on the training data sets. And then finally you can see the model evaluation. The default payment, so 1 is classified as yes, so the customer is going to make a default, is going to default, and 0 is considered no. So overall precision and recall and F1 scores looks reasonable. So this is one of the uh, model and the evaluation results. So finally, so what we learned so far, so ensemble methods which improves the model performance, bagging reduces the variance and the overfitting. So it can also be used in many practical applications such as predicting credit card defaults and many other real world problems. So in the future learning, so you can approach other ensemble methods, boosting and stacking, and see how the performance looks like. And then you can always try with experimenting with the hyperparameter tuning, like number of increasing the number of sample size or decreasing the number of sample size, and then taking care of the number of trees that you want to build. You can play around with hyperparameters and see how the model performs. And you can look for the handling the imbalanced data sets. So basically you have like if the majority has like one size, then it will impact the performance of the model. And finally you can apply to different data sets and different problems and see how the model performs. Thank you.